click record. Let's do this thing. So, hello, welcome. This is not CSCI 40. This is CSCI 1. Why in the world? We're off to a great start. Lectures. Dun, dun, dun. There we go. Welcome. And the reason I am not making this a full screen presentation is because I get much cooler pens if I keep it like this. So this is as big as I can make it and get awesome looking mark making tools. All right, so yeah, I think the first thing I want to say is just sit back, relax. I'm going to give you all these slides, all this code that I write in class on Canvas, so don't worry too much about all of that. Today's your standard first lecture. I'll tell you a bit about myself, we'll talk about the class, and then we'll actually get into a little bit of computer science and start into our first bit of ethics. Okay, so let's go very fast. Let me tell you about myself. Hello, my name is Lawton Nichols. I use he, him pronouns, and I will respond to, boop, boop, I will respond to Mr. Nichols, Dr. Nichols, Professor Nichols. But if you'd prefer, and I would prefer it if you did, please just forget about all that and just call me by my first name. Call me Lawton. Okay. So I went to Fresno State for my undergrad, not too far away. I got a computer science degree. And then I went on to UCSB for grad school where I got my PhD. So yeah, that's my background in a nutshell. This is actually my second year teaching here and my first time teaching an in-person class here. So that's super exciting. We're sharing this moment together. Okay. Yeah, I like to do normal human stuff as well as teach. I like to dance. I like to play guitar. And this is my cat. His name is Lonzo. He's amazing. This is him when he was younger. He's a bigger boy now. But yeah, he was named after Alonzo Church, who was the PhD advisor of Alan Turing. And I'm sure you've heard at least that name before, right? And I also have two tiny little beautiful moss balls, whose names I will not recite here because they're silly. All right, so that's me. Yeah, I guess all I want to really say is thank you in advance for putting up with me. This will be another exciting semester during a pandemic. All right, so yeah, let's get through the stuff that you probably want to hear about, info about the class. I'll try and go very fast so as to not bore you too much. Please remember to read that syllabus. It's all in there. Okay, let's see here. So I have to take attendance, even though you might be out sick. Just tell me if you are. Not a big deal. So we'll do that in a little bit. And then I guess my rule for drop policy is if you miss 3 consecutive classes, so pretty lenient. If you miss 3 consecutive classes, I'll drop you, okay? Just let me know if you get sick or something, and I will, of course, excuse your absence. This is not meant to get me to drop a bunch of people, okay? So that's the first bit. Let me move around on my note slides as well. So yeah, this is a GE class. This is meant to get you into the field of computer science. It's not meant to kill you, right? So it's not supposed to be a super hard class, but that being said, there is going to be some work you have to do. This is a class, right? So yeah, just look forward to learning about new stuff because I assume a lot of you have not programmed before, and that's a new way of thinking, okay? So it'll be fun. I like it. Yeah, just make sure to do the work, and it's going to be very hard to get a bad grade. All right, and that is my deal with you. Something about programming is it's kind of like writing essays. You also have to write essays in this class, by the way. But it's not really about memorizing. So that might be a good thing or a bad thing, depending on your viewpoints. But you can't really memorize things and do well in the class. That's nice. You kind of have to come up with your own version, your own way of doing some new cool thing, right? And I will be here for you as much as possible. I'll be on Discord. I'm not going to check my messages right now, but I will later, okay? So yeah, just bombard me with questions. I'd be happy to answer them. Yeah, and just feel free to yell at me at any moment if you have a question about anything. That's how I want to run my class, kind of like a Q&A session. All right. Yeah, let's see here. If you are in need of a better internet connection, The school is giving out little tiny MiFi routers, which is super nice. Look into that if you need it, and also laptops. So if you're in need of any technology, please see the resources page on our Canvas. It's in the modules, or that link to right here. Okay, so take a look at that. Take advantage of that if necessary. And yeah, let's get into the meat of what this class is about. So I want to teach you how to program, first and foremost. And then it's also supposed to be a critical thinking class. Okay, so we're going to learn how to argue about things. We're going to learn how to think logically and how, like, you can think logically improperly. So we'll learn about fallacies and other cool things like that. And we'll have a lot of debates, which I'm excited for. And all of this is meant to get you to be a better programmer, okay, to get you to think computationally, and I'll explain what that means later, all right? And then on the flip side, I want you to be thinking critically about all the stuff that we talk about. So computer science doesn't exist in a vacuum. There are some issues in the field of computer science, and we'll talk about those, okay? And the first major topic of this class is going to be ethics. So we'll have fun with that a little later today. Yeah, moving right along. And again, feel free to just yell at me if you have any questions about stuff. This is a nice small class, and we can have lots of time for questions. Yeah, so who in the world is this class for? Hopefully it's you, right? I'm going to try and convince you that this class is meant for you. It's meant for anybody who wants to become a programmer, learn how to think computationally, learn how to solve problems. It's okay if you just want to be here and you're trying to get that GE credit for a critical thinking class too. I'll try and make it worth your while for showing up. And yeah, if you're maybe a computer science major, you're already knowing that you want to program, this class is still for you. I will give you slightly more interesting problems to work on if you've already programmed, and I'll help you see the bigger picture of the field you might be going into. All right? That is my plan. And now let's get to the good stuff. Let's talk about the syllabus. Okay, so let me go and download it. It is on Canvas. Boop. Hopefully we've all had a chance to look at it. Let me attempt to open it in a new. Is it locked? I'm sorry if it is. All right. Yeah, so CSCI 1, let's scroll down to the stuff you care about. Grading. All right, so here's what's going on. The first thing, let's talk about those. You already have one out right now. That's the first thing I've assigned. Every week, I'm going to force you to psychoanalyze yourself. That's how I get to know you and see what you're struggling on, so I can help in class. And that will help me drive the class a little bit. So a very easy 5% of your grade down here is going to be from the weekly check-in survey. So just please do that. Write something. Share a meme if you want, and I will give you credit for that. That's 5% of your grade. Then the two main parts of this class are going to be essays and programming assignments. Okay, so look forward to those most weeks. You'll have one at least to work on. Okay, so sadly, in a computer science class, I never thought I'd have to grade essays as a computer science professor, but apparently I have to. We are forced to write 6,000 words of essays this semester. Okay, so I'm as excited as you, but we'll get through it together. So that's going to be 30% of your grade, and each essay is going to be weighted proportional to the assigned word. So if it's like a 750-word essay, that is worth not as much as an 1,000-word essay. Okay, something like that. And then the thing that I like to talk about are, of course, the programming assignments. Since I'm a computer scientist, you can look forward to those most weeks. If you've heard of these languages, this will mean something to you. We're going to start out with a language called Scratch, which is really cool and graphical, and then we'll move into a language called Python, which is probably the one you would have heard of if you've heard of just one of these two. Okay, so that'll be fun. And yeah, if you've already learned how to program, like if you've already taken CSCI 40 here or some equivalent somewhere else, just let me know, and I will give you programming assignments that won't bore you to death. It will help expand your mind, okay? That's the idea. Yeah, let's talk about the breakdown. So 30% is essays, 30% is programming assignments, 5% check-in surveys, and then we'll have one midterm in the middle of the semester, so like week 8 or so, and then there'll be a final for 20% of the grade. Okay, that's my plan. Standard grading scale. Yeah, we do have a textbook that I recommend that I'll be like basing my lectures on. Dun, dun, dun. So that's this one. So here's the deal about the textbook. It will help you immensely if you read from it. It'll help you on the essays. It'll help you understand what I'm talking about in class. But you don't have to buy it. I'm not going to force you to buy it. I'm not going to drop you if you don't. So just if you want to buy it, buy it. Otherwise, I can't stop you from not. Yeah, also there'll be extra credit. I like to give at least a letters grade worth of extra credit a semester, so look out for that. And yeah, this is an in-person class. It has an actual time, so we have a final exam that's set to be a certain time. Like there's a table and everything that I had to look it up in. So apparently our final is scheduled to be on the Monday of finals week, so you get to hurry up and get it over with. And it starts at 4 p.m., so it's our class time. But it lasts a little bit longer than normal class. It lasts for an hour and 50 minutes. Okay, so that's when our final exam will be in this room in like 18, 19 weeks. All right, any questions about this kind of stuff? Pause while I get water. Yes?
How do we let you know if we want the Transistor program?
You can just do them. On the assignments page, I give you an option, and as long as you just turn in the different one, I'll know that it's you. Okay, I know that was the one you wanted to do. But maybe I'll talk about that when I assign the first one. If the one that I give still you're not happy with it, we can come up together with something exciting for you that meets both of our ideas for what a program should be. Yeah, good question. Any others before I keep going? All right. We're probably all going to get sick, right? So I'm going to be very lenient with late submissions. So I'm going to accept late things, late programming assignments, and check-in surveys up to the last day of instruction. So there's no excuse to not try and learn how to program, okay? But here's the catch. The second it's late, you're going to get half credit only, okay? So 50% penalty the second it's late for those kinds of assignments. The one thing I'm not going to accept late are essays, because those take forever to grade, and I can just imagine being bombarded with a ton of them at the end of the semester when I'm trying to make a final. I don't want to do that, okay? So that's my promise for you. I'll accept these late, but not essays. So keep that in mind. Yeah. The other thing that I like to do is have a very specific due date for a lot of things. So every assignment in this class, except for check-in surveys, which will be due at 5:30, will be due at 5 p.m. And I make sure that I'm awake when things go wrong, because things like to go wrong when we're programming. Okay, you'll notice that if you haven't done it before. So that's what's going to go on. But I will extend your submission deadlines if any of these two things apply to you. Okay, so if you are a student who also works, if you work at least half time, I will extend your deadlines for all assignments by 7 hours. Okay, school doesn't count. If you're taking 20 units, that's totally your fault, right? But if you are at least working half time, 20 hours a week, let me know, and I will put you in a special group that lets your due date be midnight. Okay, that's the idea. What was I going to say there? What else? Yeah, so you can stay up late and get the assignment done. Alternatively, maybe you work full-time. You work at least 40 hours a week. If you do that, or if you care for a child or something else that is the equivalent of a full-time job, right, I will extend your due dates an extra 15 hours. So you can either stay up late or wake up early and get the assignment in. Okay, so that is, those are my exceptions to my 5 p.m. due date rule. Please let me know if any of those apply to you, and I'll hook you up. So yeah, that's due dates. Again, just keep yelling at me if you have any questions about this stuff. Because we're required to write 6,000 words of essays, I can't drop any essays, but I'll drop your lowest 3 programming assignments. So if anything goes wrong, it'll just be like it never happened if you get a low grade on one of them. Okay, up to 3. That's dropping lowest scores. Yeah, hopefully you all have had a chance to join our Discord. Please, please, please use that as much as possible. Ask public questions so that when it's super late at night and something's due, Your peers can help while I'm asleep. Okay, so do that. Ask questions publicly as much as possible, but please use your judgment. Don't give away answers or things like that. That should be maybe for a private question just to me. Okay, things like that. We'll have to keep in mind. Yeah, so just remember you can always ask me a private question, DM me on Discord. I, of course, still look at my email and my Canvas messages, but I think you can imagine as a professor, my inbox looks horrible. So please, please, please use Discord if you can, because I can see right now that I have 2 messages to respond to. Okay, that's the idea. Okay, that's Discord. What else? What else? Office hours. So my office hours will all be on Zoom this semester. Here they are. Please come to them as much as you want. You don't have to ask me, just show up. So here's when I want to have my office hours. Tuesday, Thursday, and Fridays. From these times, but we'll see if that stays the same. I'm not sure. As meetings get scheduled and things like that, we'll see. But that's when I want to have my office hours. And you can just click the link up here to join it. Okay? So please come to those if you ever have a question about anything. That is office hours. All right. Last thing that I want to talk about before we move on to attendance. Programming is a new way of thinking, like I said. It will be difficult. You will get stuck. That's just a fact of life as you start programming, okay? So let's pick a number, all right? Let's say if you are stuck for 30 minutes on some assignment, some project, and you don't know what to do and you're just staring at your screen for 30 minutes, that's when you should come to me, okay? Come to office hours, ask me on Discord, and I will get you over that hurdle and on to the next one, okay? That's what I want you to do. There is no virtue in staring at your screen for 2 hours, okay? So please ask for help. But if you're stuck for 29 minutes, that is exactly my intention, all right? So look forward to that if you have not programmed before. All right. Are we ready to finally take attendance, guys? Let's do it. So I have made a beautiful class website for us, and it is located at www.lawtonsclass.com. So please go to that in whatever browser you have installed on those machines. Maybe you have multiple. Pick your favorite. And you will be presented with a login screen. Your username and password look like this. So your username is your last name, all lowercase, no hyphens, no accent marks or anything like that. Then an underscore, and then your student ID. So like this might be my last name, this is my student ID, this would be therefore my username. Okay? If this was your last name, and this was your student ID, then this would be your username. And right now your username is your password too. Okay? So just say it twice, and you should be able to log in. All right? Let me know if you can't, or you got added to the class late or something, and I will. I'll just make your account on the fly. But hopefully we can all log in, and then we'll click on the attendance app. Okay? Dun dun dun. So I have a different view, but you'll see these things right here. You just click on attendance, and then you'll tell me one of these options. They're all equivalent, telling me that you exist and you're in this room. All right? So please do that in a second. Let me know when you're ready. But let's make sure that everyone can log in first. Is anyone having trouble? Yeah. Did you add the class late or anything? Yes.
This is the same username scheme that you're currently using.
Yes. I still work for them. It's a useful one. Are you not able to log in?
No, no.
Let me know when you're there. I can start right now. I'll just leave it running because I have to add an account anyway. So Now you should be able to click a button when I do this. CSCI 1, begin attendance. So please click any button that you want just to tell me that you're here. Okay? Now you should be able to. And we'll stay here for like a minute or so. But from now on, when the class starts, I'm just going to open up this page, and that's how you're going to tell me that we're here. Okay? Much simpler that way than calling out everyone's name. This was my summer project. Alright, has anyone not been able to click a button? Everybody, we're still waiting on. We all know what to do. In the back, yeah, what's going on? Yeah, you can't log in. Let's see that. Yeah, no capitals at all. You're trying that. Please tell me that and let us begin. I'll just leave this running so I can get everybody else who still needs to add the class, etc. Or get an account. All right, so that's how attendance will work. Let's actually have a lecture there. So something that I really like to do in class is force you to interact with each other because I don't like talking the whole time. So there is something called peer instruction. That is the name for that kind of thing. And so I'm going to ask you to answer a lot of questions on the other app here on this page. So if you make like a new tab or something, I call it ByClicker because you may have taken a giant class where you use iClickers. This is a competitor to that, but it's free. All right, so that's what I made over the summer too, and that's how it'll work out. So I'll split you into, let's say, groups, not pairs, so that you can help each other and learn some cool new thing that I'm trying to teach you, and that is you helping each other. It's called peer instruction. All right, I totally think that it's worth it. So yeah, we're gonna have our first ByClicker question. We don't have to get into groups. I'm just gonna ask you about yourselves on the next slide. Yeah, so these are in-class exercises, which people abbreviate to ICE, and our mascot here is the Crush, which is some kind of bowl or something. Don't know why we call it the Crush, but that's okay. So obviously I'm going to call our in-class exercises crushed ices. Oh yes, you may clap now. So here's what I want you to do. I want you to tell me a little bit about yourself. So please go to this ByClicker app and click A, B, C, D, or E, depending on the option. All right, so here is the first one. So please take like 30 seconds to tell me what your major is. Let's see what the makeup of the class is. Are you computer something? Are you engineering something? Are you math something? Or something else? So take like 30 seconds to answer that. And let's see the kind of people who are in this class. Let's see if I can get another desk. I'm sorry I'm in the corner today. All right, we all had enough time. Everybody wants to respond. All right, let's see what we are. A lot of us are A. Nice. No C, surprisingly, but everybody else, there's at least one. Nice, nice, nice. So a lot of us have already drunk the Kool-Aid, computer science or computer engineering. So if you've taken a class, you can help the students who have not. All right. So yeah, it's nice to meet all of you. Awesome, awesome, awesome. I'm glad that we have some non-STEM people here as well, because we don't want to exist in a vacuum. All right, so now please tell me if you've ever programmed before. So let me start a new question. Boop. So take like 30 seconds. You should already be on the page, right? Have you ever programmed before? One of the options. Please pick one. Or E if you feel like it, I guess. Let's see how we're doing on time. We end at 5:15. That should be plenty of time. All right. I see we were able to click pretty quickly, right? Thank you for humoring me. So it seems that a lot of us have not programmed before. That's perfect. This is the class for you. Welcome. I will teach you from the basics how to do it. Some of you could teach this class if you wanted to. Feel free to tag team with me if you'd like. And some of us have already programmed quite a bit. So please help the other students. Nice to meet you all. So yeah, that is the class in a nutshell. That's our little makeup. Yeah, are we ready to learn about the history of computer science? A very crash course history lesson right now. All right, and that's most of what I want to do today. Go through this, and then we might even be out early. Let's see here. So I guess if you go way back, what is computer science? It's just the study of computing things, the study of computation. What's the first machine that we made that would compute something? I would say it's the abacus, right? That would make sense. So a computer, it's just, if you look it up in the dictionary, it's a tool that helps us perform computation. Do something that we wouldn't have been able to do otherwise. And so we could add large numbers using an abacus and not have to worry too much about getting the wrong answer. It's very easy to use one, right? So that was back in the BC era. Maybe that was the first computer. We could say that. Then fast forward to the 1700s, when we have things that look a bit more like computation. So good old Leibniz, if you guys have taken a calculus class, I'm sure you've heard his name before. He, of course, invented a flavor of calculus, but he didn't stop there. He wanted to also invent binary. So I hope we've all heard of the word at least before. I'm going to teach you how to use binary and what it really means, but here it is in a nutshell. Binary is base 2. Sorry, I'm still learning how to draw on this fancy little tablet. So binary is what's called base 2, which means you only have 2 options to make numbers. You can use a 0 in the current place that you're at, or you can use a 1 in the current place that you're at. And if you want to get to 2, you have to introduce a new place, okay? That's all you get. So you start counting like this, 0, then 1, and then we ran out of digits, so we have to make the next number 1, 0, and so that would be 2 in binary. All right, so I'll teach you this in more detail, but there's a rabbit hole and it goes very deep. All right, so that's binary. He also, Leibniz started out the field of formal logic as well, which we will talk about also in depth in this class. Very fun to think about. So that was the early 1700s. That's maybe when it all started. Who knows? Then, fast forward to the 1800s, we have a dude named Charles Babbage who really, really wanted to make a machine to perform computation. So this would be a mechanical computer. That was his dream of making one of these. He never really got to fulfill that dream. He made, gosh, I forget the name. He was trying to make an analytical engine. I think that was the name, and that's the one he never got to complete. But he made a simpler version of that, I'm pretty sure. So feel free to Wikipedia him. He's a cool guy. And so this is a machine that can perform arbitrary instructions. So we'll talk about what all these words mean. And get at some answer that you're trying to compute. So, for instance, you could have programmed this machine of Babbage's to have like 3 lines of code, let's say. And the first one would be something like this. This is the kind of stuff that you could put into his analytical engine and compute. To be like, all right, I have two numbers already in the machine. They're called x and y. Let me add them. And let me put the result into z, which also exists in this machine somewhere. It's got some room for variables. And then maybe the second thing that I want to do after I've done that is take like the square root of z. It could have done that. And then I have this representation of z inside of my machine with gears and wires and things. I'd like to show that to the person who's trying to run my program. So let me print it out for them. Show z to the user who's like cranking the machine or something. So that's the kind of instructions that this machine could have performed and executed. Cool stuff, right? So he never made one in his lifetime, but that's okay. He thought about it. All right. Fast forward to 1843, so not too many years after, Ada Lovelace, or Ada Lovelace, I forget how to pronounce it. She was working with Babbage. She is the first computer programmer ever. Isn't that really cool? So her full name is Augusta Ada King, Countess of Lovelace. So she was royalty, by the way. And also, if you remember from English class, you guys remember the name Lord Byron? She was the one legitimate child of Lord Byron. I'm not saying something because I think he had a few illegitimate children. So the first computer programmer had the coolest life. Please look up her. But here is the program that she wrote. And it was meant to be run on Babbage's machine. It computes the Bernoulli numbers, if you heard of those. It's a fancy sequence that's useful. And these are all the little instructions that would be performed by that machine. Isn't that super cool? So we have her to thank, the very first programmer. We're following in Ada's footsteps. All right. Let's keep on trucking. Let's go to 1854, where Boolean Algebra was invented by a man named George Boole. Makes sense, it took his name. So Boolean Algebra is a very, very cool and powerful concept. It takes the ones and zeros of binary and does stuff to them. So we'll talk about what all this means, but the basic idea is Boolean algebra can be used to build circuits, and every single thing inside of a computer, every single piece of computation working away is really, you can whittle it down to performing some Boolean algebra operation. That's all a computer is. And so this is a very powerful concept. We'll talk about a bunch of things that you can do, like this is what's called an AND gate. It performs the AND Boolean operation. And the symbol looks like this, a little wedge. And it'll take two ones and it spits back out a one. So we'll talk about what that means and why it's useful later. Okay? But these kinds of things you can build up and make a computer. That'll be CSCI 45 if you ever get there. You'll learn how to do that exactly. But we'll give some hints as to how to do it in this class. All right. And by the way, just feel free to yell at me about anything. I love to talk about this stuff. So moving forward to 1936, so pre-World War II, we had Mr. Alan Turing thinking about what it means to compute things. Babbage had the idea. He never made his device, but he was thinking about computation. So was Alan. And Alan was thinking about, what does it mean to be a computer? What does it mean to be a computer? What can a computer do ever? Like, he came up with a mathematical specification called a Turing machine that can represent what any computer ever made or ever will be made can do, which is a very powerful mathematical concept, and that's why we love him, and we attach his name to a lot of things. Talk about like the Turing test in this class as well, which is cool. But yeah, he came up with this mathematical model of computation that can be used to represent what it means to be a computer. Crazy. And then the same year, over in Germany, this man named Konrad Zuse, he built the first what's called digital computer. And there's a big difference between a digital computer and this kind of mechanical computer that Babbage was going after. This is a a replica of it. It was called the Z3, and I think because it was in Europe, I think they probably called it the Z3 actually, but don't quote me on that. So what it means to be a digital computer is that you're only operating in terms of electrical signals. You're operating in terms of zeros or ones, which gets translated to off or on, right? Which, for our purposes, means true or false. True or false. And in terms of the circuitry, that means like high voltages or low voltages. And so these are all equivalent concepts that we'll try and get into a bit later. But they use like vacuum tubes, if you've heard of those. But this was the first computer that was completely electric, did not have any moving parts, any cranks to wind, anything like that. It just, using electricity, gave you an answer. Perform those same kind of operations that Babbage's computer wanted to perform anyway. Okay, so that's a digital computer, completely electric. Where was I? There we are. And then, after the war, 1947, at a telephone company of all places, so Bell Labs, they had a ton of money just to do random stuff, and this was one of those things. They invented what's called the transistor. And I think a few of us are engineers, right? This is probably the greatest invention of the last century, in my opinion. So let me try and convince you of that. Explain what a transistor is. It's the reason we have computers that are powerful, that can be not the size of this classroom. Okay? It's wonderful. So a transistor, it can do one of two things. It can amplify a signal, or it can function as a switch, so like a light switch. Let me show you what it means to amplify something, because that's the easier concept. So let's see here. Here's like a weak little signal, like a radio station in the air around us, something like that. And if you amplify that signal, you take the same thing and you make it giant. That's all amplification means, right? And so then we could hear the radio station, something like that. Same with the guitar. Like if you guys play guitar, here's my best drawing of a guitar. It's got some pickups, electric guitar, by the way. And you plug it in to an amplifier, right? Boop. What's it doing? The pickups have magnets inside of them, and the metal strings are vibrating away, and the magnets are, there's some kind of voltage that's being induced by those magnets into the pickups, and that's traveling along this wire as a very weak signal, and the amplifier amplifies that so we can have sound. Something like that. I'm not a physicist. So that's what a transistor can do to amplify a signal, but actually we don't really care about any of that as computer scientists. We care about the switch bit, all right? So that is the key to making a computer tiny. To be a switch, all you need to do is this. It's a electronic switch. So let me draw like a diagram of a physical switch. Like here are 2 points that could be closed or open, all right? So power could go through this from this wire to this one or not. So right now it's closed. There's no power going this way. But if I close this switch, then power could start flowing. That's what it means to be a switch. And the idea is, if we applied a bit of a voltage here, that would close this wire and allow power to run through, current to run through, and that's what it means to be a switch. So just to have this idea, to make it so that by applying a little bit of power, we can make some power go through on 2 other wires, we can build a computer. We can build all those logic gates that I was talking about, that George Boole was thinking about. We can make computers super duper tiny because transistors are super duper tiny these days. Okay? So that's super fun, ones and zeros again. Yeah, any questions about this? I'm not going to test you on transistors. Save that for a physics class. All right, let's go to the 60s, when the first bits of the internet were made. So it wasn't called the internet back in the day, it was called ARPANET. It was meant to connect research institutions to each other so that they could share information. And actually the third institution on the ARPANET was UCSB, which I went to, which is cool to think about. But yeah, just the idea of connecting computers. They didn't get around to that until 68. Crazy, huh? Yeah.
Do they have any like original that stuff at your campus?
That's a good question. Not that I remember. I know they had a bunch of little plaques on the walls and things like that. Maybe in the networking lab, they had a bunch of artifacts, but I was not a member of that lab, sadly. You'll have to go and find out now. All right. And so, still, though these transistors were relatively large, computers took up the size of a building. They were very expensive, and they weren't very easy to buy. All right. Back in the day, back in the 70s, the mid to late 70s is when all that changed. Transistors started getting small enough so you can put them into a smaller package, and people decided that they wanted one of those in their house, which was a weird concept. Like, why would I want a computer in my house? That was a new idea at the time, if you can believe that. And so the very first personal computer that was at all popular was the Apple I, made by Apple, of course. And it was invented by Steve Wozniak, this guy, and he was the brains. And then the marketer was Steve Jobs. He didn't really play much involvement in like making the design or anything, but he sold it to the rest of the world. All right, so that was the Apple I, and then they went on to make the Apple II, which was probably the most important computer in terms of getting everybody on board with personal computers. But yeah, a fun story there if you'd like to look that up some more. And yeah, that's about the end of my story. Any questions about how this class came to be? Feel free to yell at me. Because before we get into ethics, I just have one last thing to say, because I haven't highlighted it enough up until now. It's really, and it was not just a bunch of dudes making all these cool discoveries. All right, so I want to highlight 4 women in computer science that did some amazing stuff, and let me try and zoom in on their pictures as I do it. All right, so you might have heard of Grace Hopper. She has an entire yearly computer science conference named after her, actually. She contributed to programming languages and compilers. So you'll learn more about that if you take CSCI 40. I won't talk too much about that here, but just to give you an idea of how important she was, is she was the first person to use the word bug to describe a software error. We like to use that word now, right? She was instrumental in making programming languages and software. Okay? Then we have Sophie Wilson. You can thank her if you have a phone right now inside of your pocket. So she helped design the ARM architecture, which every single smartphone these days uses. And also your fancy new Macs, right? So the ARM architecture is everywhere, very power efficient, and Sophie Wilson played a very large part in making that. Oops. If you're more a fan of mathematics, we have Shafi Goldwasser. She, in 2012, won the Turing Award for her work. And the Turing Award is the Nobel Prize of computer science. You get $1 million just like you do if you win the Nobel Prize, if you get the Turing Award. So she did some really cool work on cryptography, which I am not at all qualified to explain to you right now, but I encourage you to look her up. And there's a term that I wanted to remember right now. Fully homomorphic encryption, I think. If we can make that fast, that will change the world, and that was one of her ideas. Okay? And then finally, before I move on, let's talk about Margaret Hamilton. This is a very, very famous picture. I hope you've seen it before, but if this is your first time, you're welcome, because she is insane. She led the team that helped produce the flight software for the Apollo program. So Apollo 11, we landed on the moon thanks to her, okay? Crazy. And her team that she led, they printed out the code that they wrote, and this is her standing next to it. Okay? So hopefully I've convinced you that computer science is not at all about dudes. It's not just a bunch of dudes sitting in a room writing code. It's something that everyone can do. All right. So are we ready to switch gears and talk about something completely different? Any questions about anything else I was talking about up until now? Because I want to get you ready for your first little mini essay that I have assigned for you. Okay? That's my job. So here's what I want you to start thinking about. I want you to consider these questions. Is it okay to steal to feed your family? Like you have no other way of obtaining food other than stealing. There's nowhere to go. There's no church you can go to. There's no community that you have. Your only option to feed your family is stealing. Is that okay? You tell me. Also, middle question. Should we expect any privacy on the internet? Okay? From like the places we go on the internet, from our government in general. What do you think? Should we expect to have some amount of privacy as we go outside, as we browse the internet? And then finally, these are all ethical questions, of course, by the way, that's the fancy term. Is it right to kill somebody if it means you'd save 50 other people? So these are hard questions, of course. And the hint is there is no right answer at all right? All I'm trying to do in this class is to teach you how to make a good argument, all right? So as long as you convince me or you back up what you're trying to say, you get full credit. But these are the kinds of things you have to juggle in this class. I'm going to force you to write arguments about this kind of stuff. So we'll talk about what it means to make a good argument. All right? So arguments can be, here are some adjectives that can describe a good argument. They could be sound. They could be valid. You want them to be both. Things like that. So these are terms that we'll learn later in the class. But I just want to get your brain moving right now on these kinds of things. And of course, at least one of these questions had to do with computer science. You could frame all of them in terms of it as well. Okay? So that's where I'm trying to go with this. And so, yeah, that brings us to our very first assignment. Are we ready? So on Canvas, here's what I'll do. I will release it now. Visible. So you should be able to see it now. It's a very, very quick mini essay, I call it. We have 6,000 words to get through this semester. I'm going to start you off small. Let's do 250 right now. All right? So this will be due next week. And here's what I want you to do. All right? So I want you to respond to the prompt on Canvas. It'll be a post of at least 250 words. Remember that due date. Let me know if you deserve an extension. Okay? So here's what you'll be thinking about. Respond to both of these questions, please. Is it okay to steal to feed your family? Is it okay to kill one person if it means you will save 50? And these are very standard ethical questions that you might have heard about in a philosophy class or something. Feel free, if you know these things, to expand on what you might have learned before. But otherwise, I don't expect you to have taken a philosophy class or anything. Tell me what you think. Right? Come up with a good argument. Just explain what you're talking about. If you pick a side, you should pick a side. Tell me why you don't like the other side's arguments. That's what it means to formulate a good argument, right? You talk about what somebody else might say to attack your own. Tell me that. And then, of course, there's no right answer. Okay? So remember that. There really is no right answer. But I want you to still argue your point in a convincing way. All right? So that's the struggle that we're going to be dealing with this class. All right? There might be no good answer, but I want you to weave your way towards one. All right? And feel free to ask me about anything if you're wondering about it. Okay? So that's your little mini essay, and I think that is what I want to start you with. So, just as a little taste, I'm not going to have you tell me your answers. What I'd like to do is get you used to doing this kind of peer instruction that I talked about at the start of class. Okay, so I want you guys to get into groups. So maybe look to your left, look to your right, maybe work together as a aisle or something like that. So yeah, maybe as an individual row, like you guys work together. And if you're all alone in the row, please go to the row next to you, something like that. But get together, introduce yourselves, say hi. You're all in this class together, right? And try and come up with some answers. 2 arguments for and 2 arguments against for those ideas. And I'll put the slide, or I'll put the web page back up, okay? So, yeah, you don't have to tell me your answers, but save them for your first essay, okay? And that is where I want to go with that. Okay, so here are the 2 questions. Please discuss. Take a few minutes to discuss, and then I'll bring you all back. Okay? Enough of me talking. Another minute or so, and I'll bring us back. Save that for after we're done, right? I'm glad we're enjoying the peer instruction. But let's come back for just a couple more minutes, and then I will let you be free. All right. So, we were here. Now, let us continue. One more talk here. We can talk in just a little bit, I promise. All right. I do need a bell. Should just have turned up my my timer volume a bit more. So this, thank you for putting up with me. It brings us to the end of lecture. And so what I like to do in all of my lectures is give you time to work, because these are nice large computers. I'm in the same room as you. That will be very helpful as we start programming, as we start writing more involved essays. Okay, so I'm going to pretty much every lecture, if I can, give you some extra time in class to talk to me, ask me questions, do work just in the general vicinity of me, in case you do have a question eventually. And this is like to supplement my office hours, just in case you can't maybe make them, things like that. So this is not me telling you class is over, I'm about to walk out the door and leave. Okay? So I'm going to be here until the end of class every time. I just want to say that, even though I'm going to stop lecturing before class ends. All right? And then if you finished all your work, you're of course free to go. I can't keep you here. So that's all I wanted to say. So feel free to start your essay right now if you'd like. If you work better outside, go for it. You're free to go. But I know I need to talk to 2 students at least to give them accounts on the class website. So you guys please at least stay. But that is all I have for us. Thanks for coming.